Hi, welcome to the Olympiad geometry. Let's continue our study. Before we start, if you think this video is helpful, please click the like button, comment, share, and subscribe to the channel. So here is the problem. The points P, Q, R, and ABCD lie on a circle clockwise, such that triangle PQR is equilateral and ABCD is a square. So let's just draw the figure first. And since we already know that here the points A and P are coincide, which means we can think of that right. So this is our A, B, C, D, and because PQR is equilateral, so and this is point P, so we know that we want 30 degree here, right? Roughly say it's 30 degree, and another 30 degree here. This one here. Okay. So A, B, C, D, and P, Q, R. Okay. Yeah, I know it doesn't look like a equilateral triangle, but let's just think of it. And we want to prove that the symmetric of B and D, with respect to PQ and PR respectively, which means we want to find a point, roughly say here, let's call it B prime. That's the symmetric of B to PQ, and another point, let's call it D prime, which is a symmetric point of D respect to PR, right? We want to prove that these two symmetrical points lie on the side line of the symmetrical square with respect to QR. So we want to prove that these 2 points are on the side line of the square, are on the side line of the symmetrical square with respect to RQ, which means we want to find the ABC symmetrical square of the ABCD to RQ, and we want to prove that D prime and B prime are on the this symmetrical square. And for this problem, let's just make a better figure that would be much easier to demonstrate. Again, we want to find this is A, B, C, D here. So we know this is 45. This is 45 degree. That would be easier for us to, because this is 45 degree, right? And we already know that we want to find 30 degree, which should be like 2/3 of this angle. Roughly say, I feel it's here, probably be here. Let's just find the symmetrical point here. So now we have a better figure, okay? This is P and this is Q, this is R. Think of that, we want to find the symmetrical square of the ABCD respect to QR first, right? And if we consider this AO, equals to R, right? AO, the radius of the circle O is R. This is AO equals to OB equals to OC, that is R, right? And what's AQ? So AQ equals to, because this is R, so if I do a right triangle here, we know this is 30 degrees, this is R, this would be half of R. So this would be half of R times square root 3, and this would be square root 3 times R. So AQ equals to square root 3 times R. And because ARQ is an equilateral triangle and O is a circumcenter, which means O is a centroid, which means AO equals to R, so O to this point, let's call it M. OM equals to half R, and because this O is a centroid, so AO to OM is 2 to 1, right? That means M is a midpoint of OC, right? So OM equals to MC equals to half R. Now let's think about this. We want to prove that the symmetrical point of B to AQ, which is roughly say here, for example, it's also on the symmetrical square of ABCD to QR. So let's just think about the side CB respect to QR, symmetrical side of the CB respect to QR. Because O is a symmetrical point of C to RQ, and this is a intersection point of CB to RQ, which should be the intersection point of its reflection, right? That means from O to here, this line, let's call it, for example, E. The OE, right, makes this one here, let's call it F. So OE equals to CB, right? And we know that OE is a symmetrical line or symmetrical side of BC to RQ, right? So what we're trying to prove is that the symmetrical point of B to AQ lies on OE, right? So we want to prove this B prime, this point, call it B prime. B prime is a symmetrical point from B to OE. We want to prove it lies on OE. Okay. Sorry, B prime is a symmetrical point of B to PQ, right? And we want to prove that B prime lies on OE. So if you think about this problem, this would be a little difficult way to prove that prove the symmetrical point of B to AQ lies on OE, right? We use another way, alternative way, that if we can prove, so just we draw a symmetrical line from AB to AQ, right? And we have this intersection point here, right? So because angle OAB equals to 45 degrees and angle OAQ equals to 30 degrees, right? We know this is 15 degrees and this should be 15 degrees. So we just find the symmetrical line of AB to AQ, and we let the intersection point of this symmetrical line from AB to AQ meets OE on a point. Let's call it B prime. And we just need to prove that B prime and B are the symmetrical points to AQ, right? AB prime is a symmetrical line of the AB to AQ doesn't mean that B prime is a symmetrical point of B to AQ, right? B prime comes from the intersection of the AB prime to OE, okay? So we know this is 15 degrees, this is 15 degrees, so this must be 15 degrees, right? And now the question is that how can we prove that AB prime or B prime, this point is a symmetrical point of B to AQ? We already know that AB prime is a symmetrical line of AB to AQ. So if we want to prove that point B is a symmetrical, point B prime is a symmetrical point B to AQ, we just need to prove AB prime equals to AB, right? And we know this is 15 degrees. If you think about here, because OM equals to MC and MF is in parallel with DB, right? So you may ask why MF is in parallel with DB, just because DB is perpendicular to AC, right? DB is perpendicular to AC, and we know that AC is perpendicular to RQ. So we know that MF is in parallel with DB. So because MF is in parallel with DB and M is a midpoint of OC, so we know that MF equals to half of OB, right? MF equals to half of OB, which means MF equals to OM. MF is in parallel and equals to half of OB, which means MF equals to OM equals to MC, which means triangle. So because OM equals to MF, so this is 45 degrees, right? Let's see, angle MOF equals to 45 degrees. And this is 45 degrees, so we know that angle F or angle B prime OA equals to 135 degrees. Right, that means in triangle AOB prime, we know that AB prime to sine angle, this is 45 degrees plus 90 degrees, so sine 135 equals to OA to this angle. This is 135, this is 15 degrees, so the total is 150, which means the angle OB prime A is 30 degrees. So that's OA to sine 30, which means AB prime equals to OA is R to sine 30, that's half, times this one, sine 135, which is square root 2 by 2. So it equals to square root 2 times R, which equals to AB. Right, and we already know that B prime is on the symmetrical line of AB to AQ, and AB prime equals to AB, which means B prime is a symmetrical point of B to AQ, and we already know B prime comes from the intersection of this line to OE, so B prime on OE, right? Which is a symmetrical square side of the symmetrical square of the ABCD to RQ, and for D it's just exactly the same. Okay. So this is a problem from 1970 Dutch MO. I think nowadays this problem is good for maybe 9th grade, 8th grade or 9th grade. Okay. Anyway, this is an old Math Olympiad problem. I hope you like this video. See you in next one. Thank you.